Once again in lesson 9.3, there are two major concepts, and we're going to focus on the first one, which is factoring trinomials in the form x squared plus bx plus c. How can factoring be used to find the dimensions of a garden? Tamika has enough bricks to make a 30-foot border around a rectangular vegetable garden she is planting. The booklet she got from the nursery says the plants need a space of 54 square feet to grow. What should be the dimensions of her garden? To solve this problem, you will need to find two numbers whose product is 54 and whose sum is 15, half the perimeter of the garden. I like to organize this with that same factor T that we just used. And we could look for factors of 54, so 1 and 54, that's definitely not giving me a sum of 15. 2 and 27. 3 and 18, that's a sum of 21, it's getting there. 4 won't work, 5 won't work, 6 and 9, aha, 6 and 9 gives me a sum of 15. In Chapter 8, we learned that we could multiply two binomials using the FOIL method. So first, outer, inner, last, and then we've got x times x is x squared, plus 3x plus 2x plus 6. When we combine our like terms, we have plus 5x. If we used m and n instead of 2 and 3, the same pattern works. First, outer, inner, last. But this time, the sum of 2 and 3, instead of being nice numbers, we have m plus n. So there's our sum. And m times n, there's our product. So in general, when we're factoring, we're looking for factors of c that give us a sum of b. To factor quadratic trinomials of the form x squared plus bx plus c, find two integers, m and n, whose sum is equal to b and whose product is equal to c. Then write x squared plus bx plus c using the pattern x plus m times x plus n. So for example, in x squared plus 5x plus 6, the sum of, we need to find two numbers who have a product of 6 and a sum of 5. So 2 times 3 is 6 and 2 plus 3 is 5. So to factor x squared plus 7x plus 12, I need factors of 12 that give me a sum of 7. If you can come up with them in your head, that's great. Otherwise, you can always make your little factor T. So I'm looking at factors of 12, and 3 plus 4 is 7. It doesn't matter which one comes first. I'm going to write x plus 3 times x plus 4, but you could have written x plus 4 times x plus 3. And of course, you can always FOIL it out to make sure it works. X squared plus 4x plus 3x plus 12. Sure enough, I got what I started, so I know my answer is right. This time I'm looking for factors of 27 that are going to give me a sum of negative 12. So to get a positive product and negative sum, both my factors are going to have to be negative. I know that much. Okay, so factors of 27, if I just start at the top and work my way down, 1 and 27, no. 3 and 9, yes, that adds up to 12. Okay, so we do x minus 3, x minus 9. And you don't need to write out the check, but do it in your head. X squared minus 9x minus 3x plus 27. Did I get what I started with? Sure enough. This time I'm looking for factors of negative 18. So that means to get a negative 18, I'm going to have one factor that's positive and one that's negative. Okay, so basically I'm just making my factor T, and this time I'm looking for a difference of 18. Or sorry, of 3. 2 and 9, no. 3 and 6, there we go. So we want the 6 to be positive, because I want my sum to be positive, so the 3 is negative. And as always, I'm going to FOIL it out, make sure it worked. X squared minus 3x plus 6x minus 18. Sure enough. Okay, once again, I'm looking for factors of negative 20, so I need one positive, one negative, and I want a sum of negative 1. You probably know it already, but I'm writing out my factors just in case. 3 won't work, 4, and 5. Aha, those two are 1 apart. This time I want my bigger number to be negative, so I'm going to do x plus 4, x minus 5, because when I FOIL it out, x squared minus 5x plus 4x minus 20, combine my like terms, and I got what I started with. So once again, to factor a quadratic in the form x squared plus bx plus c, find two numbers m and n whose sum is b and whose product is c. And then you're going to write it as x plus m times x plus n.